It's an absolute thrill to welcome you all to the second installment of our Pure Leadership Series 2025. My name is Winston Thomas, Editor-in-Chief of CDOTrends, and I'll be your moderator today. Before I start, I want to give a shout out to our incredible sponsor, Pure Storage, for their continued partnership in driving these crucial conversations. We have teamed up with Pure Storage because, quite simply, they are at the forefront of data and storage innovation, and together we are committed to exploring the real-world challenges and exciting opportunities in this current tech landscape. Of course, we have a special focus on AI. And also, thank you, our fantastic audience, for joining us today. I know you may have a million important things to do, but you scheduling your time is especially meaningful to us. Today, we are diving headfirst into a topic that is becoming critical: solving the data crisis. We had a data crisis like a decade ago, and we seem to have another crisis at this moment again. Today, the question we will attempt to answer is AI versus AI. Can AI solve the data crisis it created? It's no secret that AI is a data-devouring beast. The problem is that many enterprises have yet to sort out their internal data, let alone meeting AI needs for training, inference, and even scaling deployment. Then there is the storage angle, where all the data is housed. And in many enterprises, that storage tends to be older infrastructure and yet to be modernized. But we are going further. We are also asking the question whether AI holds the promise of giving us unprecedented solutions to these issues. We are going to unpack this paradox, exploring everything from moving beyond basic automation to truly intelligent self-optimizing systems, leveraging data for infrastructure optimization, and lastly, tackling the complexities of what we call explainable AI at the storage level. We'll also be debating the balance between edge and core data center optimization, as well as much more. I'm incredibly excited to introduce our distinguished panel of experts who will guide us through this intricate discussion. First, we have Anirban Nandi, VP for AI and Data at Rakuten India, which is the Global Product and Innovation Center for Rakuten Group. Rakuten Group covers e-commerce, fintech, digital AI, and data science. To give us professional advice and navigate these complex questions, we have Vijay Morampundi, SVP and AI Center of Excellence leader at Marsh McLennan. And from the solution provider side, we have Matthew Oostwien, CTO for Asia Pacific and Japan at Pure Storage, who will grace us with viewpoints from other use cases. Before we kick off, a quick note to our audience. We want to hear from you as well. Do participate in this discussion. It's not a one-sided conversation. So please use the Zoom Q&A button to submit your questions throughout any time during the discussion. Just a warning, do not use the chat button if that shows up. This is used for communications internally and highlighting any key white papers as we go through some of the topics, so look out for those. But do use the Q&A button for your questions and we will answer it. Now, let's get this conversation started. And to start it, we have a poll. So let's start the poll with our audience, because we want to hear from you right from the beginning. What are your thoughts and your key challenges in AI adoption? You get to see the poll. Please do highlight your answer. If you don't have any of the answers, you can actually state it in the other section at the bottom. We'll come back to the answers. Please continue to answer them. But let's start the discussion with a gentle question for all our panelists. Can Gen AI, data-hungry nature, ever be truly sustainable? Or are we trapped in this self-perpetuating cycle of consumption? So maybe to give a perspective, We'll start with Vijay. Vijay, could you just introduce briefly to the audience, and then let's tackle the question.
Thank you, Winston, for the opportunity. Hi, everyone. My name is Vijay. I am working at Marsh McLennan. We are a professional service organization. We help customers in risk management and also defining the strategies. I am part of AICY at GCC. I was mainly involved in developing these solutions for risk, cyber, and sustainability. So coming to the point, Winston, earlier the trend started that large volume of data and high compute will help us to get the bigger models. Of late, we are seeing a change in that approach, especially when you talk about the enterprise scenario. We want to solve the problem specific to your domain. And once you build a reasonably good model, we want to enhance these models with your enterprise data, and you want to perform in your enterprise scenarios. So it's not always that more data and more compute will help you. And one best example is that Pi model from Microsoft was released a couple of years ago. We have the recent versions. We are using them significantly. They are very small, and we are able to fine tune them on our data. And for many of our use cases, it is helping us to solve the problem. In terms of the compute as well, large vendors who are building the models, they instead of adding more GPUs, they are trying to optimize some of the key operations at a programming level so that you can do that at a much faster rate. Good example is the DeepSeek. They optimize the low programming level instead of modifying the Coda drivers. That help them to achieve the desired performance at low cost. So I can definitely say that that there might be a trend that where we may not completely look into the high data and high compute for building the models. We shift and build the models which are specific to the industry with high quality data.
When we talk about just data, Vijay, what we also talk about data infrastructure, do you see special challenges on data infrastructure, which also includes the storage and underlying storage infrastructure as well? What's your take on that?
Yes, that's correct. When now we are able to train these models, and it requires a large volume of data, especially in the enterprise scenarios. 80% of our data is unstructured data. Right. So now with the advancement of generative AI, we are able to bring this unstructured data and convert into a format that we can feed into these models, right, which can be used. So obviously storage is increasing compared to earlier. And we have seen some advancement in the way that how we are storing this unstructured data, and especially when we are creating the solutions like to feed the data through the RAG architecture to the model. So we are converting them into embeddings and storing in the vector databases. So there is definitely an increase in the model storage of the data, like we are seeing 5 to 10x increase for the unstructured data. But we need to be very cautious in terms of choosing that whichever the use cases requires you to store that embeddings at a very high level, right? Some scenarios we are compressing them where we have an option of choosing between the quality versus the storage costs. So we need to take a careful decision that where exactly you need high data at a high precision or at a low precision that will help you to reduce the storage costs.
Thanks, Vijay. I think that's excellent. We'll go to the metadata and vector embeddings in a separate question later on. Anirban, your thoughts on Gen AI's data-hungry nature, sustainable, or are we trapped in this consumption cycle?
Thank you, Winston. Pleasure to be as part of this panel discussion along with Vijay and Matt. I'm Anirban. I lead the AI and data teams as part of Rakuten's Group GCC based out of Bangalore. With regards to this specific question, I think generative AI's progress has largely been fueled by scale. More data, more compute, more parameters. But I think we are hitting a point of diminishing returns right now, where performance gains come at disproportionate energy and environmental cost. The question is whether we can decouple AI's advancements from this unsustainable trajectory. That's very important to think. Several innovations are happening in this space. Just to add on to what Vijay already highlighted, couple of years back, RAG came into the picture, right? Retrieval augmented generation offloads a lot of the static knowledge from the model weights to external vector DBs like Pinecone. Um, a lot of advancements have happened on the algorithm side. LoRa, PFT techniques allow fine-tuning only small parts of the model. Mixture of experts, models like switch, transformer, activate only a relevant subnetwork of the system. And then finally, data filtering algorithms, which is in practice very much right now, reduces training on noisy low-value tokens. These methods work because they shift from brute force scaling to smart optimization, in my point of view. And just to give a couple of more examples, maybe DeepMind's Scintilla showed that more data isn't always better. Clean, diverse data yields better results. Meta's LLM3 uses heavily curated corpora as well. I already spoke about mixture of experts. So just adding on to what Vijay had already mentioned.
Thanks, Anirban. Matt, your perspective?
Yeah. So look, I've got a few perspectives on this one, and I want to build on what my colleagues on the panel have been saying. Can we make this more sustainable, and not just environmentally sustainable, but is this trajectory something that we can continue with? And I think the answer to that is it's not a trajectory we want to continue with. And importantly, as Vijay highlighted at the start of this year, we had the DeepSeek model drop. Kind of came from nowhere. And it was very disruptive, but it was wonderful to see because I think it was an important proof point to the marketplace to say, we can build better models. There's a lot that we can do. And so if I look across the ecosystem of things that we can do as an industry to try and make this a sustainable trajectory, there's probably a dozen things. What's important to me and what's important to my customers that I'm talking to, probably I could be succinct and say there's three things. Firstly, we need to get better at building the models. Smaller, specialized models are absolutely going to be the path forward. And yes, we've seen some advances come forward with DeepSeek. I think it's the tip of the iceberg. I think we're now starting to understand that there is a lot of efficiency that can be brought into exactly how we're running these AI models. Secondly, obviously we're a data company and we think a lot about information and and how, I suppose, we're training these models. Yes, we're scraping the web, we're scraping social media, we're taking a lot of unstructured information, but at the same time, we're now seeing this emergence of synthetic data generation. It's something we're watching very carefully. There's obviously some risks associated with it that we're trying to manage via guardrails to ensure that we're not, ingesting, to use the term AI slop, but it is genuinely a path forward for more efficient information that we can feed into the models. And I promised you three things. I guess the third one is going to be, how do we build out on greener infrastructure? Okay. It is astonishing to see the progress that's being made by organizations like NVIDIA with the amount of performance coming from their next generation systems. But I think there's probably some work that can be done on how much power is needed to actually power these systems. Because it is rather high. And the same can be said also for how we're storing this information and what kind of networking infrastructure, to say nothing, of course, from the broader grid of how we're powering our data centers. So really the trinity to me comes down to improving that model, improving the data that we're putting into the model, and then of course making sure that we run that on greener infrastructure.
Great. I'll pick on those points. Thanks for that, Matt. But let's go back to the poll answers. And the question was key challenges in AI adoption, and we are asking the audience. We have the poll answers. Right. Not surprisingly, cost is number one. It's the biggest challenge. And on this, let me see. We have at 38% performance, and interestingly, data sovereignty is on third place. So looking at the answers, Vijay, what do you think? Expected?
Yes,
Or is
Winston,
there
I
a
think
different dimension to cost here?
yes, I think it's an expected trend, especially in the enterprise scenario, as we are trying to scale the solution at an enterprise level. Cost is the main factor, right? You have thousands of employees and the customers who are going to use your solution, and you need to be very, very cautious about the cost. This is where shifting from larger model to the domain-specific models will help us to keep the costs at an optimal level. And I can also see that performance, and there are many use cases that which requires very good performance, right? So performance improvement is an iterative process. We need to build the feedback loops and get the real-time data from the users and help it to improve the solution over a period of time.
And data sovereignty, I guess it's expected because
Yes. Yes, that's how every country and organization, they're trying to keep the data within their own sovereignty for regulatory compliance. So it's very equally important.
And Anirban, what's your thoughts as looking through this?
So absolutely expected results, and that's where I am building using generative AI to build POCs is one thing. Putting it on scale with a lot of AI inferencing, where you are getting millions and millions of hits every day from customer-facing applications, is a different ballgame. We realized this problem long back, and that's why 2.5 years back, we made a strategic decision to invest in our own large language models. So Rakuten AI has two large language models, one a 7B, one a 56B, both fine-tuned on top of Mistral. And the 56B is actually a mixture of experts model, which we released spring of 2024, even before DeepSeek came into the picture. And all the process and it was taught, the world was taught about how optimization, cost optimization could be done. So very proud of that achievement. Uh, However, along with cost, I think if I look at it from an enterprise angle, one of the major challenges, keeping aside the data sovereignty bit into, is turning data into decisions at scale. It's kind of related to data. Most of the enterprises have massive volumes of data across different businesses, but connecting that data to actionable, explainable outputs, especially in real time, is still evolving. Bridging this gap between raw data, clean pipelines, and model consumption requires constant re-architecture. And because I'm speaking about re-architecture, the next bottleneck that I also feel is around integration. AI pipelines must plug into legacy data stores, customer systems, ERP stacks, actually without breaking them. You need to adopt features to SKU flow, microservices API for modularity, but there's still work to be done in productionizing fast enough to match the model prototyping pace right now in the industry. So that's my point.
I got a quick question, Anirban. Especially looking at the business of Rakuten itself, when you look at the data storage infrastructure, which is at 31%, do you feel that as we move to moving some of these models to the edge, especially where decisions need to be made, do you feel the data storage infrastructure is going to be an issue, and that itself will feed into the cost?
Absolutely. And specifically, we also have a SLM, which is a mobile edge device SLM, which is currently live and also available on Hugging Face, right? But yes, you need to be very, very cautious. And specifically, if you are operating across different businesses, we are not an enterprise, we are a conglomerate. So we have businesses across e-commerce, fintech, telco, all of them have their own data storages. We also use a hybrid cloud environment. So it's pretty complicated that way. And you need to be intelligent to operate within those realms to actually make your AI work. So without getting into the specifics about how we make it work, but you need to have intelligent systems, both from the infra data as well as modeling systems.
Okay, thanks. Matt, I'm not going to ask you about costs and performance, but what I will ask is why meeting ESG goals and a need for more computing power, especially when it comes to energy, always comes at the last. It's like one or two, there are people who are worried about it, but not enough.
Well, I've got a few takes on this. I think it's low, but it's growing. I think it describes the fact that we still have a bit of the gold rush fever when it comes to AI. People are excited. Organizations are looking at the growth and potential that it brings to their business. And I think it's got the attention of the board and the CEO. And when the board and the CEO gives a directive to the organization to say, we need to be investing within this space because we believe that there's opportunity to grow markets, to extend into areas where we haven't been doing business before, or perhaps drive efficiencies, then that's rather intriguing. And at that point, when you're focused on growth of your organization, then the meeting of ESG goals, I think, becomes deprioritized. It's not that it's not important. I would also say that in my experience, the language of conversation has shifted with customers around ESG. Let me put it another way for you. There is a finite amount of kilowatts that's available within a data center. And at the moment, research shows about 25% of the power is dedicated towards storage. We have these new generation of NVIDIA systems that require a great amount of kilowatts. And we're now reaching thresholds in customer data centers where they're unable to deploy as many GPUs as they want because they're meeting these thresholds. So now the conversation isn't about sustainability, it's about redeployment of the power that I do have available to me. Why do I need to spend 25% of my total amount of power on spinning disk when I could be spending 1 or 2% using flash-based storage techniques and then redirecting that so that I have more power available to me from an NVIDIA GPU perspective. That's going to be more important, I think, in many of the conversations. As a former researcher, I do want to make the comment, whenever we don't see cost come out as number one, it's a shock. So irrespective of the type of tech that we talk about, you ask what's a priority for a customer, of course, cost comes out at number one. But I do want to pick on a really important point that Anirban made, which was really interesting. And correct me if I'm wrong, Anirban, but essentially there was a nugget of information that says there's a lot of POCs and there's a lot of pilots being run out there. And yes, technically it may work and economically it may work at that particular scale. And then the customer goes to try and put that at a full-blown enterprise grade scale, perhaps in a hyperscaler and public cloud, and they realize that economics just don't stack up. So cost is one thing, but I think how the cost is being consumed to the organization matters. And before we leave the poll, because I love the poll, Winston, it's one of my favorite parts of these. I do want to just touch on data sovereignty really quickly, because watch this space, everyone. Sovereignty is big now and it's growing. We're seeing it being the number one conversation point in Western Europe at the moment. And I think given some of the geopolitical machinations that are occurring around the world, there are some valid questions being raised by IT leaders at the moment about what the ownership of the underlying data sets are, and of course the digital sovereignty of the underlying infrastructure as well. Now, this is important in the context of AI. It's important because firstly, we want to ensure that the training data that we're using to ingest and train our models is indeed protected and is indeed within the jurisdiction that it belongs to. But I think as we move from training and starting having discussions on inference, when we're really starting to see personal information being ingested into these models, then it becomes absolutely mission critical. And a lot of the conversations that we're having with customers in India, in Japan, in Australia, around the Asia Pacific region is to say, hey, we may need a different architecture here to better align with the future that we see moving forward when it comes to the needs of sovereignty and the decisions that are being made by our organization.
Yeah, that's a great point, Matt.
Just to add on, Winston, if I may, on Matt's point. So Gartner just released the hype cycle for AI for 2025, few days back. What's very interesting to see that both Edge AI and generative AI is now through the true of disagreement. What is at the peak of inflated expectation is AI agents, AI-ready data, and sovereign AI. So just to add on and validate what Matt was just saying, sovereign AI is going to be one of the big things this year, next year, maybe. So
Anirban, quite curious. Thanks for sharing your journey within Rakuten in terms of coming out with optimized models. How did you convince your management to go on this journey right before? I mean, you would have gone through this at a time when OpenAI was just building up ChatGPT and all the fever was there. How did you manage to convince that this
I
is
think
the
a lot of, yep, sure. I can share a little bit of our story as well. So, um, all this started when we were we started conceptualizing our own LLMs, SLMs, vertical LLMs when we started putting things into production. And we started seeing the cost of using OpenAI models. We are not very dependent on OpenAI, so we use OpenAI. We have partnerships with OpenAI, we have partnerships with Google, Anthropic, a lot of them. And that's when you have to kind of strike a balance with the board of directors and the investors, saying that are we looking at short-term cost or long-term cost, right? Because the moment you start building your LLMs, SLMs, your own foundational models in-house, your short-term cost is still higher than using a API call from any of the service providers, right? So, but if you show like a 2-year goal, okay, 3-year roadmap on the cost side, that this is with certain assumptions, you will clearly see the benefits of having your in-house models. Plus, even now, a lot of our applications is not completely dependent on our own LLMs or SLMs. It's a hybrid model. We conceptualize this concept called as LLM routing as well, okay, to optimize costs. So there are a lot of different ways. It's not just, I don't think there is a solution where you'd say that, okay, doing this for an enterprise is the only way to go about this. You will have to be intelligent, work around the systems to eventually figure this part for you.
Okay, thanks. Going to Vijay, you mentioned about vector embeddings earlier on in our discussion, and I just wanted to pick your brain how this is actually impacting storage or even data strategies. The reason why I'm asking that is now with reasoning models, vector embeddings and metadata is just growing out of proportion. So is there new strategies or is there a different approach that you're taking, especially with now with reasoning models where it is always people accuse reasoning models of too much wastage in terms of data? Vijay?
Yeah, thank you for that question, Hamilton. I will take it in two parts. One is on the vector embeddings part. So I will talk about a scenario which I worked in a startup a few years ago. Those were the early days of generative AI. We are working with a private equity firm for building a solution. So there is a large volume of unstructured data in the terms of documents. One of the first challenges for us that it's a terabytes of data. So how do we bring in the right data, gold standard data that we can use it to as part of the RAG approach to send it to the models, right? So we need to spend a good amount of time in curating the data, creating the gold standard data. Through that approach, we are able to reduce the overall volume of data by a significant factor, by more than 10% of it. And subsequently, once you have the gold standard data, we look at the downstream use cases which we want to work upon. And we identify the right set of data that we want to convert into the embeddings and storing in the vector database. Yes, when we created the embeddings, especially for some complex use cases, we used to go with high dimensional vectors, which used to take us up to 10x of the storage in considering the indexing of these algorithms. We are using some of the best of the indexing algorithms for high precision and accuracy as part of the retrieval. And we need to be very cautious in terms of seeing that which of the use cases you need to capture the information at a very high dimensional level. Not every use case may not require, right? So you pick that very carefully. And later we have seen a new type of embeddings, that Matsukaishi embeddings, where you can expand and compress the embedding so that depending on the use case, you can use it. So we use some of those techniques and we are able to reduce from 10x to 5x. And still that's a big factor. And like the way you said, it's not only the embeddings that we are storing. Now we store a lot of metadata about a particular document and artifact, right? So this is a very, very important, crucial decision. One way it helps you to retrieve the information faster because you are relying on a few key tags to search for the information, right? So you might not able to save the storage, but you might able to reduce the performance cost while you are retrieving it. So we applied some of those techniques to identify the right tags, only necessary tags that are required for us, and store them in a vector database. So it increased. Finally, what we did is that we applied the quantized techniques to reduce the size of the embeddings. For some of the use cases, we are able to reduce the size by 90%. Of course, there is a challenge in terms of the quality, but we are able to overcome by using the second level of re-ranking techniques where we use the cross encoders to see which of them are more relevant for our use case. So by applying some of these techniques, we are able to balance the storage cost versus the performance. That's how we are dealt on the embedding side vectors. Coming to the other point, right? So we are talking about the reasoning models. Reasoning models is a completely different ball game. Like the way Anirban said, we also try to use the routing techniques to see which of the input queries that we want to send it to the reasoning models. Not every question is so complex enough that you need to use the reasoning model, right? There might be some straightforward questions that we can use a simple straightforward model. So we need to make that decision of, in an enterprise scenario, which of the task really requires reasoning. And I will just add a scenario here. One of the company Fractals from India, they are able to build a reasoning model, especially for the maths, at a very low cost. So again, it's not that you need to build a very complex models to do the reasoning. So if you pick a domain and if you have the right reasoning traces for that particular domain, you can able to fine tune the models, reasoning model that will perform very good, equally better to the large models for every domain use case.
Thanks, Vijay. Before I go to Matt, to echo some of the learnings that you just shared, Vijay, I'd like to ask the audience, please do participate in this discussion. I know it has been interesting so far. Do use the Q&A button, just send in the questions, and you have your chance to actually ask some of your questions to our panelists here. Back to you, Matt. What Vijay has mentioned, what are your thoughts?
Well, I think the way I interpret the question is, what's the data strategy, what's the storage strategy, and how's that changing when we're looking at, say, metadata, or when we're looking at the embeddings. From my perspective, it's wildly different. It's pushing the storage strategy, at least, to being very object-centric. This is an object-oriented world, so we're moving away from block focus, away from a file focus, more towards storage that's capable of supporting, these hybrid vector relational databases, and we're going to need tiered architecture behind that to do it. Listening to some of Vijay's commentary, it really aligns with what we're seeing as well. Storage isn't about space anymore. It's not about the amount of capacity. It's around fast retrieval. It's around how does it work with semantic search? What's the interaction with contextual indexing? And how do you do this at massive scale? That's the other question here. So the shift from where we see it increases the complexity. It certainly it can increase the cost if you're not architecting properly, which I guess aligns with the audience poll. And now with richer workloads, I think more traditional flat storage is going out of favor towards a tiered approach that is able to be dynamically responsive to the needs of the model that's sitting above it.
Out of curiosity, Matt, looking at it from your perspective in terms of engineering solutions and answers for what the market needs, how has that shifted the way you approach in product design and delivering some of these wants which might you might need to even predict as the trajectory goes to actually solve that?
Yeah, it's a good question. We've been working within this space for probably a decade. Maybe it's better described as an HPC environment earlier than an AI environment. But what we started to find was customers, as they increased the level of complexity, particularly around the metadata, they add more tags, there was more bounding boxes, there was more annotations being placed upon the data. That had a really profound impact on the underlying infrastructure itself. So when we're talking about metadata, we're talking about hundreds of thousands, millions, billions of small objects. So massive amounts of I/O. And it is opposite to the data flows that you're seeing coming in or being ingested. Perhaps it's a video file or some other type of informational ingest where it's massive data file and there's not much pressure on the I/O. What you're asking the storage to do underneath then is two very different things. And what our customers were finding was that they were hitting I/O bottlenecks. So the overall performance of an HPC system, as more complexity was added from a metadata perspective, was being reduced. So we started seeing this many years ago, actually, in an HPC environment at NASA. We obviously have our storage environment supporting the world's biggest AI super research cluster, which is over at Meta. And we've learned an enormous amount, obviously, from working in those environments. And what our architectural approach is today, particularly when we're starting to talk about larger exascale size environments, or at least getting into the hundreds of petabytes, is that the better architectural approach is actually to split your data and your metadata. So we have a storage architecture now where essentially some of our systems are being used as a metadata engine. That metadata engine is interacting directly with the underlying data nodes, and the performance increase that customers are seeing is rather profound. And in fact, this architecture that we're testing at the moment with NVIDIA, it is available, but we're finding that it is actually the fastest storage system on the planet for some of these larger installations. So we believe it's the right path forward, but we've certainly listened and learned a great deal, not just in this last few years of the ChatGPT iteration, but really that basis of work that we've done from the HPC world now starting to find itself in an enterprise environment. So that's the shift now that you're starting to see from Pure, particularly around supporting these large AI environments.
Is that a similar situation that you feel that you face, Anirban, from your side?
Definitely, yes. So I think all modern organizations go through is kind of going through the same challenges, right? So two things, like Vijay said. First, maybe my point of view on the reasoning models, and then something around the vector embeddings. So specifically on the reasoning models, Vijay gave a very nice example of Fractal being able to achieve that. But the hybrid architecture that can actually blend symbolic reasoning with deep learning, like using GNNs or CSPs with LLM, can definitely deliver better reasoning. Sparse attention modular agents are more efficient than your monolithic models anyways in the first place, right? These methods work because they tailor the compute to the task specifically. A constant satisfaction programming layer can enforce logical constraints that LLMs alone often miss. GNNs are good at handling structured data better than transformers. So sparse routing let us reactivate or activate only what's necessary, keeping the latency and cost in check. Again, going back to the first question and the poll results, where how do you keep your cost in check? Now, with regards to vector embeddings, not now, but even a decade back, were a central to a lot of enterprise problems. And Matt did mention about semantic search, right? Now, semantic search is a lot of enterprises enabled semantic search even before OpenAI released ChatGPT, right? But the problems with vector embeddings is as their volume grows, especially across multilingual, multimodal, and version formats, traditional storage strategies, I think, buckle under pressure here. Okay, and that's where a lot of stuff that Matt was talking about, pure storage and modern systems use vector databases integrated with object store, embedding lineage trackers. These techniques actually help with indexing, semantic hash trees, and embedding pruning to help manage scale and relevance. So as an enterprise, I think you have to be really, really cognizant about all the new upcoming technologies happening around both to make your reasoning models work efficiently as well as all the innovations happening in the vector embedding space as well.
Thanks, Anirban.
Can I just
Go ahead.
jump in, because that's really on point, and I think as an infrastructure organization, it's great to have architectures and it's great to have things that are faster, but what really matters are the people that are working on the tools and the people that are building these models. And it's our job, I suppose, to make storage as invisible as possible. What I don't like to hear when I'm having a conversation with a customer is to say that they're now making concessions, limitations to how they're building their model based on the underlying infrastructure, whether it's the storage or the network or anything else. They are deliberately holding back from what is truly achievable within the organization because they just don't have the systems underneath to be able to support that. And I think it's our role as suppliers in the marketplace to say, what can we do better to ensure that you're more efficient, that you're not waiting for a response from the system. AI researchers are incredibly talented people that are in very high demand, and they obviously don't want to be sitting around waiting for work to be done. And at the same time, organizations that are hiring them want to make sure that utilization rates of these people are as high as possible. So, that's, I think, one of the primary objectives, and it needs to be when you're building out solutions to be able to support this group of people. How do we make them more efficient?
Thanks, Matt.
Yeah,
go ahead.
Winston, can I add one more point on top of Matt? Okay.
Sure.
One liner. Matt, absolutely spot on. I think, and specifically I've seen from my own experience and with all the network that I have in the AI world, the AI researchers are always not at pace with everything that's happening at the storage layer, right? That education is very, very important. And like you just said, if your team can do a little bit of education for the enterprises, well, this is what's coming. This is the most modern thing, right? You use it as the baseline and grow on top of it. So it's very important for them.
Thanks. We have around 15 minutes of discussion to go through. And again, a shout out to our audience. Do send in the questions. I don't see any of the questions. So it looks like we are having a very clear conversation and discussion at this moment. Please do send in your questions. Love to hear your thoughts and comments, and I would like to put them across to our panelists. I'd like to switch topic to explainable AI. It's one of the topics that I was looking to actually approach. Now, I'm looking at it from an implementation point of view. How do we reconcile the need for explainable AI, looking at a data infrastructure point of view, especially when it needs to link or integrate with frontier models that is coming up? Maybe Vijay, you can start that discussion.
Okay, I will share my experience in two parts, right? The one is from the infrastructure side, another is from the providing explainability at the model output level. Few years ago, I'm working in the healthcare domain where we are planning to train the models for image processing, medical image processing. There are large volumes of 3D data. So which was stored in a very large storage, and we need to retrieve them, and then we need to process them in the NVIDIA GPUs. We are using 100 GPUs, I think V100 GPUs at that point of time. And so we that time when we are doing the training, sometimes our training runs in a distributed fashion used to take longer. So we used to look at the underlying causes. What is the bottleneck in terms of the taking longer time. So there, the right level of information, the observability information that we are getting, right, will help us to explain the underlying bottlenecks, which we are able to fix it and able to improve the data loading time by 40%. That's one of the good thing that we are able to achieve. All of that happened because of we had the right observability metrics, which are able to explain to us the underlying bottleneck, right? That's on the infrastructure side. So now moving on the model output side. So many a times in real world scenarios and enterprise scenarios, so we can't just trust the model output without understanding how the decisions were made, right? How it is able to produce the final output. So even when we're using the machine learning models, we used to look at what features are driving the output. When we're processing the images, we also used to look at the salience maps or gradients to see that which part of the image is influencing the output outcome decision. That's how we used to do in the earlier days. After generative AI, mainly working on these use cases, we are, especially in the enterprise scenarios, the way we look at it that when when the output was produced, we are always providing the enterprise context data, right? Which of the input source data was used as a context, and which of those your documents or the paragraphs that were used, right? Chunks were used to produce the final output. So we are tracing back the output to the source of information. So that way, our users will be able to know that how the output was produced. I will give you one more example. Last year in my previous company, we worked upon the natural language to SQL generation. Right. So this is a scenario where many times people will ask the question in the natural language, they may not understand the SQL statement that was generated. So what we used to do is that apart from providing the regular output in the text format to the users, we also provided them the metadata in terms of what tables were used and what attributes were used to generate the data. And that kind of information, explainable information, will help them to understand how the output was generated. So what I observed over the years is that the more explainability that you bring into your solution approach, it will increase the trust among the users, and which indirectly helps you to adapt the solution in a better way.
Out of curiosity, does it actually go through, does it actually impact your storage decisions? Or
Yes.
data infrastructure decisions?
Yes, we do. Say if I want to trace it back, which other source was used to produce the output, right? So we need to have that mapping across the output, and so we are also storing the little additional information. So it definitely has some level of impact on the additional storage and additional information that we need to keep track of it, right? And we are also logging this information mainly to understand which are the scenarios where we are not able to do it in the right way, right, which will help us to improve the models. So it is increasing, but it is helping us to improve the solution at a better for a period of time.
Anirban, you got your thoughts on this?
Yes, explainable AI, or in short form XAI, is one of the closest or is one of my favorite topics. And reason being, I authored a book around explainable AI 2 to 3 years back. See, overall, the field of AI has been in existence from 1950s, so we are close to 8 decades, if I'm not mistaken. And if you look at the first 5 decades, 5.5 decades, you'll see that most enterprises would use data sciences, analytics, AI, but the usage of the models would be relatively low on complexity. So if you just have like a 2 by 2 metric where you have low complexity, high complexity, low explainability, high explainability, you will find that people are using models during that point of period of time, during the initial few decades of AI journey, which are low in complexity because that gives high reasoning power. And that's the model structure in itself. Whatever data you feed in, if you use a simpler model, the explainability is already very, very high. But and then deep learning came in, and then there was deep learning architecture, transformer architectures, which led to all the GPT models, right? So to address this, one of the things we potentially do is to wrap the frontier models with tools like SHAP, Lime, integrated gradients, or even token level attribution maps are paired with this black box models. It is not easy. It's a solution that you have to develop once the output is there. So it's an additional effort to make this model outputs explainable. Now, these methods work by isolating the actual causal influence, highlighting potentially which tokens or embeddings drove this decision. The surrogate models often, like I was talking about, trade-off granularity for clarity. So overall, it's a solution. The entire space is relatively new. Specifically, on the deep learning side, there has been some bit of work which has happened. But on the transformers, the generative AI, the LLM models, it depends. It has to be another algorithm, and there's nothing which is readily available for you to plug in and say that I can make my output explainable to a certain extent.
Okay, thanks. To the audience, we still have a bit of time. Please do send in your questions. You'll also see from your chat window that we are actually supplying some links. Please do also download them. Click on them and download them. These are part of discussion that we're having, and we hope you do have a good time actually reading through some of these insights. Now, I'd like to end on a topic which Matt alluded to right at the start of this conversation, which is synthetic. That was point number 2 out of the 3 points that he highlighted. So I'm just, Matt, so synthetic data created by AI to train other AI, is it solving the data crisis, or is it deepening an authenticity issue and creating another problem?
Yeah, I'm normally an optimist and rather bullish with my technology. Synthetic data, I do see promise in. I just want to put an asterisk next to what I'm about to say because I think we need to proceed with a little bit of caution here. There is absolutely an upside to the capability for synthetic data to be able to alleviate some of the scarcity, perhaps reduce some of the bias when it's very well controlled. I think that in specific use cases where particularly Vijay was talking about research within the medical industry, some very industry specific and bespoke data sets where we're able to firstly reduce bias, which is very important from a medical perspective, where a lot of the ingested data might come from Western countries or countries that have better systems of record to be able to standardize that, but it needs to be very well controlled. Okay, and I'm very cautious of moving to a future where we're ingesting data that risks eroding authenticity, whether we're going to start amplifying this model echo chamber phenomenon that we're seeing. And I suppose that the other downside is being able to mask some of the real world use cases. So it's a powerful tool, yes. I'm seeing some examples where it can be applied. They're very specific use cases and they tend to be industry specific use cases as well. But we're now at a point where we're training data or we're training our models off data that has really reached the peak and the limit for where we're scraping from. We're now at the point where obviously we've ingested everything Wikipedia has to say. We're now looking at comments in Reddit and YouTube and so on. I think that there's a different future, a better future that awaits in how we can synthesize data sets that are going to be better able to feed these models and produce better outcomes. So look, it's got potential, but there's a big asterisk next to it, Winston.
Anirban, your thoughts on this?
Completely agreed with Matt. I think synthetic data holds a lot of promise for domains where real data is scarce, biased, or privacy sensitive, right? Maybe healthcare, cybersecurity, or when you're doing a rare event modeling. But like Matt said, it also risks deepening authenticity issues if we can track or validate it and then use in training. Specifically, if I can talk about something connected with synthetic data, you need to have a strong annotation platform. create data, you annotate with a human in the loop as well. So this is where the AI and the human synergy comes into the picture. You don't generate just synthetic data because it's statistically mimicking your limited set of data and put it in a model, right? You need to ensure that with the AI human synergy, you annotate it properly, make sure it's bias free, make sure it has a little bit of variation as well. Sometimes the problem with synthetic data is the level of variation created within the newly formed data is very, very limited, right? So it is unable to learn the deviations. And therefore, when it's actually doing the AI inferencing, there's a problem. It always leads to similar kind of outcomes, right? So synthetic data, lot of promises, but my strong recommendation would be AI human synergy, use an annotation platform on top of it to create variations.
Thanks, Anirban. Vijay, last thoughts?
Yeah, so I agree with Matt and Anirban on this. Especially synthetic data is very, very powerful if you use it in a right way. There are multiple scenarios in my use cases, especially in the regulated industries or healthcare. So to meet some of the edge case scenarios, we have to generate a synthetic data. It helped us to improve the overall model performance. But what I definitely say is that we need to look at the utility of the data and see that whether it is matching with the real world distribution, right? So if you don't take care of the bias in the data, so you might not be taking care in the right way, which will help you to reduce the overall performance. But if you use it in the right way, it helps you to get the desired results.
Thanks. We're coming to the end of our discussion. There is one question that it's sort of interesting, and I'm going to pose it at because he's smiling at the camera. What if the AI engines are run on a CPU stack? What will be the impact on storage and power requirements?
In the interest of time, I'm going to be slightly glib, so my apologies. What's the impact? Well, you're going to use more power and you're going to use more storage because it's going to take more time. And it's a less efficient path forward, and I wouldn't recommend, but if that's the tools that you have available to you, then that's what you work with.
Right. Thanks for that. And I would like to end this with giving each of our panelists 1 or 2 minutes to just summarize our discussion. Maybe Vijay, you can start. What are your thoughts?
Yeah, so thank you, Vincent. So what I will take away from here is that greener infrastructure is one of the key aspects. You need to define a right architecture, both for the data storage and training and inferencing. Inferencing is going to be much bigger in future. So we need to really design the right infrastructure for the inferencing. And second thing is that smaller domain-specific models are going to gain more traction. And I already seen some example that Anirban has quoted. So I see that it's going to be the future for us. And the third aspect which I see is that companies following the ESG and sustainability, how AI is going to help them to achieve those sustainability goals over a period of time. So those are my takeaway from the session. Thank you.
Thanks, Vijay. Anirban, your thoughts, your key takeaways?
Sure. I think as we look at the infrastructure as a whole, one thing is very clear in my head. We are no longer just talking about scaling models. We are scaling, but scaling it with responsibility and trust in mind. The foundational tensions which we all spoke about, like data hunger, model drift, and growing complexity of embeddings, are roadblocks, but also if you do it well, are not roadblocks through design, through mitigating challenges through design, right? They are actually pushing us to think beyond the brute force and towards a more intelligent, purpose-built AI systems. Specifically from an enterprise standpoint, I think across enterprises, we are not just experimenting with these geographies and platforms, whether it's vector pruning in e-commerce, edge optimization AI in telecom, or responsible Gen AI for customer support. Our focus remains clear that building AI that scales with context, with control, and with consequences. Because finally, in the end, I think AI isn't just about making things smarter. It's about making things more meaningful for the end consumer, right? And that starts with us building systems that are not very far or accurate, but aligned with business goals, regulatory needs, and above all, I think human values. Thank you.
Thanks, Anirban. Matt, last words.
How about this? The infrastructure decisions that you make today will lead to your ability to execute in the future. Choose wisely and think about what it is your organization really needs to accomplish. The re-injection of trust within the model, the ability to be able to deconstruct silos and harvest the data that you have available to you, the ability to drive down cost, and that simplification that's required at the fundamental layer. We live in a world in IT where we talk about deconstructing silos. Okay, we risk recreating and building the silos of the future today if we don't think very carefully about what that data platform and strategy looks like. And it's worth the extra thought to get it right so that we get better outputs in our models.
Thanks, Matt. And this has been an incredibly insightful and thought-provoking discussion. So I really learned a lot. We delved into the foundational tensions, as Anirban said, on AI's data hunger. We looked into the challenges of implementing AI, especially Gen AI. And we also looked into explainable AI and touched on synthetic data, all because we are looking to see whether AI can give us solutions. And as you can see, topics which are quite urgent and the answers are there, but it's still evolving. And something that we will have to look at in terms of continuous innovation, of course, ethical considerations. And at the end of the day, it's all about partnerships as well. We can't do it all solo. Now, at this moment, I would like to know how well we did in the discussion. So there is a QR code that will magically appear on your screen. Please do scan the QR code and tell us your feedback. I've been told that this can be done under 30 seconds. So please do share, and whatever your feedback is, we will use that in consideration for planning of our next sessions. Also, look out for the links that we will send, that was sent over the chat button. If you have missed any or have issues finding them, don't worry. We will send them via an email. So please keep an eye on your inboxes for follow-up emails containing all these additional materials. Now, on behalf of Pure Storage and CDOTrends and all our panelists today, thanks for coming over and spending time with us in this discussion. I hope you loved the engagement and the thoughts that was shared, and made this actual discussion quite truly dynamic and something a lot from. We do look forward to seeing you at the next Pure Leadership event. Until then, stay safe and have a good week.